for? Who am I going back?
I think.
Don't play it with him. I have my please.
My speech on.
Hi Hannah, I got this one for you.
Thank you.
Are you doing
Hello. So sorry. Thank you.
Alright, how are you today?
where is it?
Where are you going? How much you know, Lee? How are you doing?
Oh, no.
I'm cool. Hi, Addie.
Hi.
For you. How's it going, Anna? Good. Good.
I just like, I think it's
Hi, Brady.
I
I can open your notes that you had uploaded.
Okay.
I'm not sure what the file type was. Okay.
I don't know if it
If you can,
You can redo it like a Word document.
that'd be awesome. Okay.
Yeah.
So on number 13B, it says, please indicate the following registered the periplasm on the slides, it's supposed to be gram plasma. But you labeled mine wrong, even though it's positive. I can zoom in.
Okay, I'm sorry. That'd be great.
It's all good, I just saw it and I was like,
I'm
I
looking
thought
at
that
this
was
file, like, I
positive.
can't.
It's all good.
Right now, Frank's doing it. Balloons.
Yeah, you don't sound very good.
No, I'm just trying to go to class, so I'm not gonna say USA Canada finals.
Think so? I think US plays either Switzerland or Sweden.
I don't think that, yeah, the. That's strong compared to the USA.
Is that for you?
There you go.
It was good.
Hi, Grace. Good, how are you?
They're tied right now, one of them is
What are you watching?
P. Yeah.
I, college life, and post something.
And Colin, I got this one for you.
Emails my website.
Happy Monday, February 9th, everyone. It looks like I misgraded one of the exam questions. It's number 13E. So I probably misgraded everybody. So I will be adding a point to everyone's score rather than collecting all exams back. So I'll work on that one probably this afternoon, and then update your score on the grade book. So I apologize for that, and thanks for letting me know. All right, we do have an extra credit opportunity coming up for this afternoon. Mallory is ill, but Megan, do you want to speak to this event here?
It's right after this. It's gonna be short, like just come make a few cards if you have time. But they're going to the nursing homes all around Adrian, so if you're not doing anything, come make a few cards.
All right, very cool. And where do we go?
I don't know how to pronounce it. The room right in front of here.
Georgia. Okay. All right. So Megan's gonna keep a tally of names there. So 5 extra credit points for those who can help out. Go back. The other item is that we do have a speaker coming in tomorrow afternoon. This will count for our lab assignment. So for those of you who normally come, have the 10 o'clock lab, come to the 10 o'clock lab. So we're going to do some street plates. But then I'm going to give you time later yesterday or tomorrow afternoon to go to the presentation. And it's going to be at 1 o'clock in this room. If you can't make it, I will record it for you so then you can watch it later for the lab points. For those who are scheduled for the 1 o'clock lab, just come to this room at 1 o'clock, and then after the presentation's over, then we're going to go to the lab. All right, any questions about that one? So if you're to the 10 a.m. lab, go to the 10 a.m. lab, but then try and make a 1 o'clock presentation. For the 1 o'clock lab, come to the presentation, and then afterwards we'll go to the lab. Well, we've been learning about how to control microbial growth. So just as a quick review, do you remember what some of the main themes were that we learned about last time? We learned about different kind of physical methods of controlling microbial growth, like what kind of heat?
Moist.
We got moist heat and dry heat, very good. We also learned that control methods there's a lot of factors that can go into the decision upon what kind of method you employ. So what are some of those factors? Well, we learned about the type and number of microorganisms can play a role. What else?
Is it risk of infection?
Risk of infection. So whether that item is being placed like in or just on the body can play a role too. Yeah. All right, so we're learning about, we're going to continue learning about those physical methods of controlling microbial growth. So last time, we left off looking at heat. Then we're going to take a look at filtration next. And then after that, then we're going to jump into some different types of chemicals that can be used. Yeah. All right, have you used a setup like this in chemistry labs before for filtration? Yes and no, okay. So the idea is that we have an open container, a cylinder up at the top, at the bottom, which has a place for a filter. And remember, microbes are super small. We're measuring them in terms of micrometers or microns. So for bacteria, the average size here is around 1 to a 5, 1 by 5-ish. And so the pores that allow the liquid to flow through have to be much smaller than 1. So that's the reason why we see the 0.2 micron size for the pores. Can you imagine having to make that? I don't know how they make that thing. All right, because the pores are so small, water flows through it very slowly. And so to try and, make it go faster, they'll attach it to a vacuum, like a suction, to suck the water through the filter. All right, so we're talking about a method to, physically separate microorganisms away from the water, the liquid. It doesn't have to be water, but so what are some of the disadvantages of using filters? Anyone?
Too much filtration. Too much filtration.
Yeah, what do you mean by too much? Or
Shooting in the dark here.
Okay. Any thoughts about disadvantages of using filters?
They get clogged.
They can get clogged very easily. That's true. So you have to change filters all the time. Right? Also, not everyone has a vacuum pump, right? Because I'd love to filter my drinking water, but I don't have a portable pump with me. All right, so filters work, but there are some disadvantages, right? Well, similar to the way that we can use filters to remove bacteria from liquids, you can also use filters to remove microbes from the air. So I think we talked before about how it's nice if we had some HEPA filters, for our room. I don't think those are HEPA filters up there. Because, similar to the other filter that we saw, the HEPA filters have very small pore sizes. Again, we're looking at that 0.3 micron range. So, because of that, it's going to really restrict airflow. Air is not going to penetrate through that kind of filter very readily. So you have to, force a lot of air through or have a huge vacuum behind it. But nevertheless, it does work. Right, and then we can also use irradiation. So we're talking about using electromagnetic energy here. So this spectrum here, or diagram here, kind of reminds us of the different, various forms of electromagnetic energy and how they differ based on their wavelengths. So remember, light has properties similar to that of a wave here, and then the distances between these peaks can be measured, and we call that a wavelength. And then you can kind of see here that on the scale that these different forms of energy differ based on their wavelengths. So we have longer wavelengths on the right, much shorter wavelengths on the left, and we give them different names. So on the very far right, we have radio waves. On the very far left, we have gamma rays. And then energy is related to the wavelengths or the frequency, so that if we have higher frequencies on the very left, that's higher energy levels, longer wavelengths on the right, lower energy levels there. Okay, so how does that relate to controlling microorganisms? I know, you're just thinking, I like the pretty colors. But we need to kind of relate what we see there to the subject of this chapter. How does this relate to controlling microorganisms?
Some of them might be only seen at certain wavelengths. Some of them only might be seen at like certain wavelengths and stuff like that.
Well, yes, but we also need to think about relating this to killing microorganisms.
Does a wavelength have to do with survival? Because the UV light disinfects hospital rooms. I mean,
Yeah, we can kind of think about which wavelengths would be more effective at killing these microorganisms. For example, you've experience with using UV versus radio waves are ineffective. Okay, so that's the idea here, is that the wavelengths that have the higher frequencies are getting more effective at eradicating, killing these microbial organisms. Okay. I mentioned previously that irradiation is very effective, at those higher frequencies at killing microorganisms. And some countries use irradiation to kill microbes that are on fruits and vegetables, like these strawberries here, in order to preserve them and prevent food spoilage. So this is more common like in Europe. I believe even in Canada they do this, but not so much in the United States. So yeah, I mean here's a really good example of how you can use irradiation for food preservation. And why do we care? Why do we care if food spoils or not?
don't want to get sick.
What?
You don't want to get sick.
You don't want to get sick, but you're eating foods maybe that are spoiling, right? And also think, big picture. The majority of food that actually is grown in the United States actually doesn't get eaten. I mean, that's just how serious food spoilage is. I mean, there's just so much that actually ends up going to waste. Either, there's food that ends up at the grocery store that doesn't get purchased because it spoils, or foods that are purchased end up being spoiled before they're eaten, or you actually have foods being spoiled even before they reach the supermarket, the grocery stores. So at every step in the food production chain, there's, losses of foods. So, in this country and other places around the world, hunger is an issue. And if you have the majority of the food that's being grown not being eaten, that's a serious problem. All right. Well, what about the microwave? I highlighted this one here. I mean, you may be tempted, right? You purchase some food, and you notice, oh my gosh, my strawberries, which I really like, are starting to get moldy. Maybe if I just zap them in the microwave, they're safe to eat. Have you ever thought about that? Okay. we did see microwaves on that electromagnetic spectrum, but they don't pack as much energy as those other forms of radiation. So yes, they can heat up, but the microwaves themselves are not very effective at killing microbes. So the heat that they generate, though, heat is effective. We learned that about dry and moist heat. But this last point is that the microwave doesn't heat evenly. So that's the reason why you've seen those turntables inside of the microwave to try and move the foods, because there's uneven heating going on there. So I know you may be tempted to microwave that item, but that itself isn't an effective way, is not an effective way to prevent microbial growth. Well, we actually saw last time, you remember the name of that big pressure cooker that has the door similar to that which you see in a submarine? You remember the name of that? The autoclave. That's right. The autoclave uses steam, moist heat, plus high pressure in order to kill microorganisms, reach temperatures up to 121 degrees, which is above, centigrade, which is far above that where water normally boils at. And that high pressure is also very effective at killing microorganisms. So one example would be like apple cider. I don't know, has anyone grown fruit? Anyone have like live on an orchard or anything like that? Okay, like for fruit orchards attract a lot of birds. Because birds like fruits too. And whenever you have birds that are eating food, what happens? They poop. They poop. Where do they poop? They poop when they're perched on these trees, so they end up pooping on the fruits. So, whenever you have fruits, you're going to have a lot of animal poop on them. So you need to kind of, clean and you want to disinfect, right? So, with apple cider, you've probably gone to these cider mills. They take the fruits and, they rinse them off, but they just smash them and, to get the juices out. And a lot of times, you'll end up with contaminated cider because there's just too many microbial organisms that are originally on the fruits. So you need to try and eradicate those. So high pressure is actually very effective, for trying to prevent those kind of organisms in our ciders and other fruit juices. All right, so we talked about a lot of these physical methods. Now we're going to transition into different kinds of chemicals. So there's like different classes of chemicals that can be used to eradicate organisms. Sometimes these organisms are referred to as germs. Have you heard that term before? Germ, G-E-R-M. And so chemicals that kill these organisms are called germicides. Okay, so we have germicidal chemicals, so that would be like an adjective. All right, some considerations here. Similar to what we learned about before about how the setting and applications are very important in deciding what kind of control method to use. So too with these kind of chemicals. Just by their nature, these germicides are going to be lethal to cells. So I mean that's why we're using them, is to kill microorganisms. But at the same time, we don't want to harm ourselves in the process of using these germicides. All right, so let's look at some examples here. Do you remember what percentage of ethanol that we're using in the laboratory to disinfect our tables? That was 70. Yep, 70%. So someone actually did a study to see, what percentage of ethanol is most effective and most lethal. I know you're probably thinking, oh, it's 100%. No. It's actually 70. So you actually need a little bit of water in there in order to make it more effective. Okay, let's see some of the advantages and disadvantages here. Ethanol evaporates very quickly, and why? We have limited contact time. So remember last time we talked about that D value on that one graph, where it kind of showed you that you need a certain amount of time in order to kill 90% of the organisms. And so, that D time can vary, but that's the idea there, is that, well, if you have a liquid that's evaporating very quickly, you may not have enough contact time in order to kill those microorganisms. Okay, and then depending upon the item, that ethanol can actually damage the materials, right? Especially if it's if you have something made out of soft plastic, that ethanol can dry out the plastics, make them more brittle, and then they end up breaking. And plastic items don't last forever. Have you noticed that? They do break. All right, well, what about for human use? Well, have you ever noticed what happens to your skin if you put, alcohol on it? It dries it out. That's right, so when it evaporates, it'll pull out that water from your skin. So, not the most pleasant thing to use, right? All right, so knowing that there's some disadvantages there, people have actually looked for other kind of chemicals to use to prevent microbial growth. So we have a class of compound chemical functional groups called aldehydes. All right, so I don't know if you remember from chemistry class, you learned all these different names for functional groups. So aldehydes are the ones that have the carbons with a double bond, oxygen, and a hydrogen attached to it. So we have some examples there. You may have heard of formaldehyde. Formaldehyde, because that's the one that was historically used to preserve specimens. So when you were in high school, did you do any dissections? Yes? Okay, what did you dissect?
I dissected a cat.
A cat? A frog? Pig? Yeah. Good. Yeah, go ahead. A squid, really nice. All right. Now, normally, if you have a dead animal, what would happen to it? It decomposes, right? It breaks down. And why is that? Well, because you have these microorganisms called decomposers that break these things down. So in other words, if you treat those dead animals with these kind of chemicals, it'll prevent the decomposers from decomposing. So then you have your specimen that you can dissect. So, well, all right, and then the last note here is probably a carcinogen. Okay, well that's not good. Well, what does that mean, carcinogen? Cancer causing. Cancer causing. So most of those preserved specimens don't contain the formaldehyde anymore. But some of those other agents aren't real friendly either. So just kind of make a note of that. Okay, so we have ethanols, we have the aldehydes, and now we have the biguanides. And the most common example of a biguanide is called chlorhexidine. We have chlorhexidine. This is a chemical that has often been added to liquids, things like very strong mouthwashes, to like lotions, as well as just hand sanitizers and things like that. And they're used in antiseptics. Do you remember what that means, an antiseptic? Anyone remember from the example with Listerine? Like Listerine is an antiseptic. Anyone remember? Yeah, think a little bit more broadly.
You're looking for disinfectant?
It's a disinfectant, but like how does it differ from like bleach?
What was it, instant? Running time on? I'm asking. Like instant? You don't need the time on the...
Oh,
I don't know.
yeah, we're thinking something else here. It's supposedly safe for human use, so human contact. So it's like the mouthwashes inside or maybe outside use there, as long as you follow the prescribed guidelines there. All right, then we have ethylene oxide. And this is an interesting one because it's a gas. All right, so what are some of the advantages there about using a gaseous agent instead of something in the form of a liquid? Like the chlorhexidine would be in a liquid.
We're not really able to see it. You can see the liquid, so you can't really tell where the toxins are going to be.
Yeah, I guess that would be like a safety problem, right? You can't see it, you don't know if you're breathing it in. So let's think of so that's actually let's think of an advantage of having a gaseous type disinfectant versus a liquid disinfectant. there's a number of considerations here. One is that it could be related to material that you're trying to disinfect. Maybe you would have something that you don't want to get wet. I have paper. I want to disinfect. I don't want to spray with a whole bunch of liquid, right? And maybe you have an item that has a lot of nooks and crannies in it, like your laptop with the keyboards there. Like, I don't want to put liquids on the keyboard that might actually damage electronics. But the gas could actually get in there and clean out the insides for you. All right, so there are some advantages to that. And as Brady noted, you can't see it, so you don't want to actually inhale it. So that could be dangerous, right? And boy, we got something that's, could cause cancer, so we don't like that. And on top of that, look at that. It's explosive. And what do you do after you're done using it? Put it out into the atmosphere for everyone to breathe. All right, so maybe we should not use that. All right, moving on. We have halogens. We got the periodic table over there, but remember that there's a column there with elements that we refer to as halogens. So that includes chlorine, that's the active agent really that's in bleach here. So it's very, very effective. So probably from for the general population, this is probably the easiest form and best agent that that's most readily available. Like, you can't necessarily get a whole gallon of the biguanide, but you can get the bleach. Now, the bleach that you purchase from the store is highly concentrated, so you want to dilute that with water. Okay, so leave like a 1:100 dilution. So, like, what does that mean?
Add a bleach in a 5-gallon bucket.
My
Mom always said.
Let's say you were in a laboratory and you actually could measure things out precisely. Like, what would that mean?
1 part bleach to 100 parts water.
Yeah, so it's actually, technically it should be like 1 part bleach, 99 part water to make the 100. So that's where it's a little bit misleading there. So yeah. All right, then we have iodine. So I can't remember if you worked with. Yes, you did work with it, right, for the gram stain. So remember, that's the stuff that was in that. I believe it was in a brownish tinted bottle. It's kind of a yellowish solution. Why was it in a brown bottle? What do you think about that?
Sensitive.
It is sensitive to light. That's right. So it become inactivated. Yeah. And the iodine is in a liquid form, and a lot of times, instead of just adding water, people will add alcohol to it to make it more soluble. So that whenever you use alcohol as the solvent, then we call that a tincture. A tincture. So mixing iodine with the alcohol forms a tincture of iodine. I did mention before that this is actually one way you can treat drinking water. So, if you really have to, if you are unable to boil water, let's say that you don't have electricity, you can't, get a fire going or whatever. If you can't boil water, you can actually put iodine in there and drink it. It doesn't taste good, but you can drink it. All right, metals are also can be used to kill microorganisms. Back in the old days, they used to make coins out of actual silver. And in the old days, people used to have to make their own medicine. We're going back in time here before you had Rite Aids and CVS's and all that. You had to kind of have knowledge of the world in order to kind of make your own, treat your own illnesses and things like that. So one of the things that people used to do was to take their metal coins, like silver, put them in a glass of water and let it sit for a while. And the metals from the coin, small amounts of it would actually leach out into the water, and then they would drink the water. So that would kill microorganisms that would potentially infect their bodies there. People don't do that anymore. So now we have antibiotics. So similar kind of concept there. You're consuming something that would kill the organism. All right. Use of metals is actually discouraged in this day and age just because it's a source of environmental pollution that's very difficult to clean up. Okay, here's another gas, and this one's called ozone. So ozone's a gas. I don't know, does anyone have a hot tub or anything like that? Do parents home have a hot tub? Okay, well, whenever you have a large pool of water, like a swimming pool, that could be a source of where microbes can start growing. So, instead of dumping in chlorine, one thing that you can do is you can put ozone into the water, and that will help kill the microorganisms that are present. So you can, literally, put ozone into the water. One of the problems, though, is that it breaks down quickly. So, I guess there's some advantages. You're jumping in a hot tub. You're not going to be sprayed with all this ozone, but at the same time, remember that some of these agents are more effective if they're present longer to kill these microorganisms. Yeah, so that's a nice alternative to chlorine for home use. All right, something that you probably have used is hydrogen peroxide. Have you ever used that on like a cut or wound? You know, you put it on there, it kind of bubbles after you put it on there. Okay. So what's going on there? Hydrogen peroxide is this one. It's the H2O2 right there. And there are enzymes called catalase. This one right here. This is an enzyme that will actually break down the hydrogen peroxide. And then the bubbles that you see, that's oxygen. That's O2. Okay. So the hydrogen peroxide is good, but it breaks down very quickly because as soon as you put it on, it starts breaking down. So it's like. Actually, one of the tests that we're going to do in the lab is we're going to actually put hydrogen peroxide on your bacteria to see if it has, you know, this enzyme or not, and then catalase. Okay, so here's something that's in addition to bleach, you know, that's readily available, but bleach by far is more effective. Okay, then we have, how many more slides we have here? We have phenolic compounds. So, like, there's a whole range of different kinds of phenolic compounds, but they all share that benzene ring with a hydroxyl group attached to it. That's a phenol. A benzene. Remember, benzene is that? It looks like it's got those six-sided shape to it. Yeah, there's lots of different kinds, but triclosan is one example of a phenolic. It's been used in like soaps, that kind of thing. Sometimes I think it was originally also used in toothpaste. But you don't see it used anymore. And that's the problem with a lot of these compounds, is that they not only are harmful to microorganisms, but they're also harmful to people. so that's a reason why you don't see triclosan used as widely as it was before. Okay, I'm trying to get to one more slide here. Then we have these quaternary ammonium compounds. Quaternary ammonium compounds. So we have cationic detergents. Okay, so you have cations and anions. Cations and anions. Okay, one's positive, one's negative. You remember which ones are which? Okay, what are they? Very good. So these are positively charged detergents. So detergents, by their nature, have a hydrophilic and hydrophobic region. They form these micelles. They're spheres where they can encapsulate hydrophobic substances, like oils, and encapsulate them so that they can be solubilized in water, so that you can wash them away. Okay, this is our last slide here. So we're looking at chemical preservatives. So you probably noticed when you buy processed foods, there's a whole list of ingredients inside there. A lot of them are these preservatives here, meant to prevent microbes from growing. Here's one, denote nitrate to nitrite. So some of you like to eat ham. I seem to recall that. Was that you, Emily? I don't remember. But some of you like to eat that pink meat. Why is it pink? because of all the nitrates and nitrites that are in there as preservatives. So one of the benefits is that it prevents Clostridium botulinum from growing. Remember, that's the one that grows from the hard-to-kill endospores. So we don't want people to get botulism. But the problem is, these processed foods, because of those nitrates and nitrites are present in high levels, are highly associated with cancers. So if you kind of look at the list that, you see so many lists that are being generated these days. What can you do to lower your risk of getting cancer? And on, like the top 5 list, you're going to see do not eat processed foods, specifically the ones that are in meats. Do not eat the processed meats, and you will significantly lower your risk of cancer. Okay, so what should I eat instead? Well, eat the unprocessed meats. You can buy pork that has not been treated with nitrates and nitrites. Does that make sense? All right. That's a good way to end today's lesson. You don't have to get cancer.
A good sandwich, though. Really good sandwich.
Right. All right, everyone. Remember 2 o'clock, card making, virgin room, right? Yeah. All right, and then I'll see everyone later.